Okay, welcome back everybody. Again, I'm still fooling around with the lighting in here, but I think I've almost figured it out. So what I'm going to do is tonight, I'm going to cover, there's a light right up here. You can see the glare on the screen right there. Makes it kind of hard to see. I'm going to cover that light off, and then so it'll be okay then. Anyways, let's get back to looking at average and annual returns again by asset class. Because what I said before was average returns are not the same as an annual return. So what do I mean by that? Well, let's go look at page, where is it here? Page 266. Table 9.2. So notice, let's just look at stocks, for instance. Now, if we look at the average, again, I just want to look at the average return for 2010, 11, 12, 13, 14, 15. So on a yearly basis, we saw that stocks had an annual return of 15.1%. Then something happened in 2011 where our annual return was only 2.1. So maybe that's our portfolio. Then it jumps up to 16%, 32.4%, 13.7%, 1.4%. So that's on an annual return on an annual basis. Now, if we take our average return, okay, our average return is for a period of greater than 1 year. So in this case, the average return for 2010 to 15 is 13.4%. So again, that's a combination of 2010, 11, 12, 13, 14, and 15, where the annual return is just for that 1 year. Okay, so one doesn't really relate to the other. Like one, the annual return is part of your average return is probably the best way to look at that. Now then we can see here, right? Before on that slide, we said that stocks have outperformed bonds on an average return basis. And again, we can see that for the most part here, right? Look at our average return for 2010 to 2015, 9%, okay, compared to 13.4%. Usually the annual returns are all higher than the bond as well. But there's an inverse relationship too, where if we have a high return on a stock, the return on a bond will be low, and vice versa. Okay, if we have a high return period on a bond, usually that's indicating something is wrong in the economy, where we're having a higher return on a treasury bond versus a stock. Okay, so a bond is more for protectionary purposes, especially government bonds. Okay. All right, so again, just looking at rates of return. What does this mean now? Again, what is 21% versus 33%? So on a dollar basis, again, just going back, yeah, we did earn a better rate of return. Or sorry, dollar value speaking, we had a better dollar return on Imperial Oil shares. But if I would have said to you, you have $5,000 plus $60,000. So that's $65,000 total. What would be the best mix for you to make the most amount of money? You can invest $65,000, either some in Afria, some in Imperial Oil, or half and half, or would you rather just put whatever other type of investment mix you want to make? Well, if I had $65,000, which we did because we spent $5 on Afria and $60 on Imperial Oil, I would have been better off to go buy $65,000 worth of Afria shares, okay, rather than Imperial Oil shares. Why? Because the rate of return on a percentage basis was higher. Okay, so that would have gave us the most amount of return possible. And again, we can only tell that by looking at our percentages, okay, our rates of return. Okay. Let's go now to page 266 and look at historical risk. So this is computing volatility. So we want to look at the risk of our asset classes, and we want to compare our risk versus our return. So reading along from the textbook, financial theory suggests that investors should look at an investment's historical returns to assess how much uncertainty to expect in the future. Okay. So in practical terms, okay, the finance industry uses a statistical return volatility measure known as standard deviation. Okay. So standard deviation is the square root of the variance, which represents the total risk of a security or a portfolio. So one security, meaning one company share, or shares of one company. A portfolio would be a basket of your investments. Okay. So again, that represents the total risk of the portfolio. Again, so we're going to learn, how do we calculate standard deviation? Well, it's the square root of the average deviation of those returns. Okay. So we can look in the textbook. We have our return. Okay, we know our returns might be, well, let's just look at example. In the textbook, it says, find the average return and risk for Mattel since 06. And it shows the annual returns for the years 2006 to 2015. Okay, that's fine. So 52.1%. And then there was in 06. Then in 07, we had a decrease here. What's this? Hold on for a second. I gotta figure this out. Okay, so getting back to this, I don't know. I'm just looking at example 9.2 in the textbook. I don't like how they calculated this out, but whatever. So the first thing that we want to do, if we want to figure out our standard deviation, okay, for a period, let's look at, for Mattel, they've given 10 years. So they had a 52.1% rate of return in 06. In 07, they had a decrease. They had a minus 10.5, minus 28.5 for 08. I don't know why they're putting in the average percentage return of 14%. I wouldn't include that. I would just take our average annual returns, add them all together. We get 140%. Okay, 52.1 minus 10.5 minus 28.5. These are all the annual rates divided by 10. So now we get an average annual return for the period of 14%. Okay, so I'm going to jot that down up here. So we have 14% as our average rate, average return rate. Now what? So from there, we can calculate our standard deviation. Okay. So how do we do our standard deviation? Well, we'll take this is where we need the 14%. Okay. This is in the textbook. Again, now my marker's running out. Get the red here as well. So our year one, 52.1% rate of return. Minus 14% average squared. Plus, let's go to our second. Minus 10.5 minus 14%. And then lastly, in year 10, we have minus 5.2% squared minus 5.2% minus 14% squared. So we would square up each one divided by n minus 1, which in this case is 9, right, because n equals 10. So we calculate that all up, and we get a standard deviation of 30.5%, averaging 14% rate of return per year. Okay, so we can use that when we're doing 915, and 916. Okay, again, take a look at example 9.2. It gives a good explanation. Okay, so we figured out our average, our yearly average. Now we know our standard deviation, which helps us look into the volatility of a share or a portfolio. Now, if we were to look at the risk of an asset class, okay, so we know that stocks are the most volatile investment. They're more volatile than a bond. They're more volatile than a T-bill. Okay, so let's go take a look at table 9.3 at the top of page 268. Okay, so now we look at, okay, so our standard deviation, what is that telling us? Well, the standard deviation is a measure of risk. Okay. Now, the risk of a security or a portfolio. So now if we go look on table 9.4, okay, before I said table 9.3, it's actually 9.4. We can look at our standard deviations of stocks, long-term T-bills, and long-term treasury bonds. Okay. So let's just go down to the 2000 to 2009. So the standard deviation was 20% for stocks. That on its own, again, that on its own means nothing. We need to have, if we're going to do an analytical review of risk, okay, we need to have something to compare to, because again, that 24.4% on its own means nothing. So we'll compare that to the T-bill. The T-bill standard deviation was 1.9%. The Treasury bond was 10.3%. Why would T-bill have such a low standard deviation or measure of risk? Because they're backed by government. Okay, the government isn't going to go bankrupt for the most part. Okay? Whereas stocks, that's a fairly risky investment on occasion. Okay, notice the standard deviation for 2000 to 2009 was 20.4% compared to, again, bonds 10.3%, T-bills 1.9%. So when we get into those periods, we can start to look, okay, this was a scenario that caused stocks to go up, okay, in order of risk, okay, and this is why, again, it's inverse. When stocks have a high risk, bonds are lower risk, okay, T-bills are even lower risk, okay. So again, it's just a measure of risk, and we can help determine if we want to take on those risks of that stock or of that portfolio. Again, just a measure of risk, okay. Again, various types of asset classes, T-bills, stocks, and bonds. Now, lastly, okay, we're going to look at coefficient of variation, okay. Now, it's very safe to buy a T-bill, okay. Now, it says here, investors can buy very safe T-bills, or they can take some risk to seek higher returns. How much extra return can you expect for taking more risk? That would be looking at the coefficient of variation calculation. Okay. So we'll take our amount of risk divided by the return. We can also use standard deviation divided by the average return. Okay. And that would give us an amount that we can use to analyze our risk versus return. If we look at example 9.3, that gives us a good analysis. Okay. So just to wrap this up, take a look at page 270, risk versus return. The coefficient of variation. Basically, take a look at what it means, how to calculate it. You might have a multiple choice on it, but that's probably as far as we're going to get to that. All right, that wraps up today's class on corporate finance. We will see you tomorrow.